Hello everyone, here is a presentation video on one of the imaging modalities, which is the functional magnetic resonance imaging. The entire presentation will cover the introduction to the Fmri, its working principles, its applications in clinical and also research areas, the advantage, disadvantage, and the precautions will also be covered. So stay tuned. Before everything else, what does a medical imaging mean? It is a method of visualizing tissues by analyzing the interactions of certain energies being transmitted to the specimen. There are different methods or modalities to generate this medical image, and the Fmri is one of them. The Fmri, which is an abbreviation for functional magnetic resonance imaging, is a modality that measures brain activity by detecting changes associated with blood flow. The technology is the same as that of the MRI. We will revise the concept of the magnetic resonance imaging in the upcoming slides. Historically, this MRI concept was discovered around 1930s, and in 1990s, a physicist named Seiji Ogawa found the relation of this magnetic field and oxygenated blood interactions. And such studies has progressed far, and these times, many researchers are working with it in an advanced manner. Before looking into the Fmri in detail, we must clearly understand what the MRI is. The MRI is a non-invasive test using a strong magnetic field and radio waves to create an image of the body. It is based on the nuclear magnetic resonance principles, which is a technique to obtain microscopic, chemical, and physical information about molecules. The MRI works by developing the fact that the nucleus of the hydrogen atom behaves like small magnets. The hydrogen atom is composed of a single proton, and these atoms act as a small magnet in our body. When there is no magnetic field applied, the protons are oriented randomly. It's also a clinically important medical imaging modality due to its exceptional soft tissue contrast. The components of MRI. The MRI has the primary magnets, radiant magnets, radio frequency coils, and counter system. The MRI system uses magnetic field and radio frequencies rather than ionizing radiations. The primary magnetic field refers to the strength of the static permanent field, usually from 1.5 to 3 Tesla. When a strong magnetic field is applied, the hydrogen atoms align parallel or anti-parallel to the applied primary field. This is called longitudinal magnetization, and which is in the direction of the primary magnetic field, the z-axis. The protons spin on that axis, and this is called precession. The precession rate is called the Larmor frequency and given by this formula. Exposing these hydrogen atoms under radio frequency wave will step them out of equilibrium. The proton will jump into higher state by absorbing that energy. Then removing the radio frequency signal will bring them back to equilibrium position. This will generate a signal. The gradient coil by itself generates secondary magnetic field over the primary field and are used to image spatial position of the MR signal. This in short has described how the MRI system generates a 3D soft tissue image. Now the Fmri, back to the topic. The Fmri stands for Functional Magnetic Resonance Imaging. It measures the small changes in blood flow occurring with brain activity. It relies on the fact that the amount of blood that flows around the brain and its activity are directly related. When an area of the brain is engaged, the blood flow to that region also increases, which is oxygenated blood. The main concept here is the BOLD, which is an abbreviation standing for blood oxygen level dependent. The Fmri detects BOLD changes that arise when changes in neuronal activity occurs. As we have seen in the MRI technique, here magnetic field and radio frequency excitation will also be applied. Then the hydrogen atoms will emit radio frequency energy, then return back to equilibrium. The scanner measures the sum total of the emitted radio frequency energy that decays over time, and image will be generated. Areas of the brain which are active will have increased oxyhemoglobin around. That results in an increased image intensity. And on the other hand, the increase in concentration of deoxyhemoglobin causes a decrease in an image intensity. This is because the deoxyhemoglobins introduces an inhomogeneity into a nearby magnetic field, while the oxyhemoglobin does not. The applications of the Fmri. It's basically used to examine the brain's functional anatomy. That is to determine which parts of the brain are handling critical functions. It's also used to evaluate the effects of stroke or other diseases, to guide brain treatment, to enable doctors to get inside our mental processes to determine what we are thinking and feeling. It also might even be able to detect whether someone is telling the truth or not. The fMRI has a great advantage over other brain imaging techniques since it is non-invasive and does not use ionizing radiation. It also has no risk if it's correctly done, and it has a better spatial resolution. But still, it has some disadvantages, like it has low temporal resolution and it cannot show the activity of individual neurons. The fMRI involves a strong magnetic field, therefore care should be taken while the scan is to be done. Patients which have magnetic implants are not allowed to be scanned with the fMRI machine. Also, pregnant patients and patients with history of head trauma or fainting should not take the scan. Finally, the fMRI uses standard magnetic resonance imaging scanner, instrumentation and technique to measure the brain activity related to changes in blood oxygenation and form an image by combining good spatial and reasonable temporal resolution. Thank you for attending this video. I hope you enjoyed it.